Hi, my name is Colleen, and today I'm going to take you to the Douglas Creek here in Gordon Head, which is a suburb of Victoria, British Columbia. So here is the start of Douglas Creek. This is where the headwaters are. So this is where the river or the creek starts. Fun fact about the Douglas Creek watershed, it is a salmon spawning area. Right now there isn't any salmon as the water is pretty cold and it is nearing November. Douglas Creek is actually a much larger system. It is a huge watershed that covers 558 hectares approximately. It outlets to the ocean, the Pacific Ocean, which is Cordova Bay more specifically. As you can see on the left there is Mount Douglas, which is where a lot of the precipitation on top of the higher topography falls down into Douglas Creek. As you can see, a lot more would come into the watershed and then into Douglas Creek and then into the channel of Cordova Bay. You can also see on this map, you can tell that Douglas Creek is a meandering stream, and as it is November right now, it is the heaviest rainfall Victoria receives. So therefore the creek will most likely be the most filled with water at its highest amount. As you can tell around me, it's quite a very lush green environment. That is because Victoria is a CSB. This is classified by the Köppen-Geiger system, and that is because that makes it a very mild climate and good amount of rainfall. Here in Victoria, especially we're in a rain shadow, so we do get less, but we still get a pretty good amount compared to other places. And it's relatively warm here year-round. It isn't too extreme in temperature changes. As you can tell, the topography is way higher up here than it is down at the riverbank currently. It gets quite steep as you head down towards it. This is the most, I've walked by here a couple times, and this is the most definitely highest amount of discharge I've ever seen at the creek here. Definitely a high amount of velocity coming out and energy exchange going from the top here to the bottom. As you can see, the sediment curtain is slowing down the flow of the river by a great amount, and that is so it doesn't overwhelm the channel below, which we'll go down further and see. You can see there's quite a huge change in velocity right where the curtain is, so it goes from quite a fast pace here to quite a slow pace here. It's a lot more low energy after it hits the sediment curtain. The curtain is also put in place to prevent flooding onto the bank, as there is a storm surge currently. The further you head down Douglas Creek towards Cordova Bay, there is a weir on the way there that does filter out a bunch of the rainwater. It also, the large volume of water from a heavy rainfall can overpower the limited water storage capacity of the weir, and will allow the contaminants that it's trying to filter out flow over the structure and continue downstream. When this happens, this can wash out the salmon spawning beds and erode the creek bank. As you can tell, there is a storm surge right now, and water is overflowing over the weir. And you can also see that there is a large change in velocity as soon as it hits the weir. It becomes even faster and greater change of velocity once it's hitting the weir and then flowing over top and continuing down the creek. Here's an image showing how the weir works and how the flow is affected by the concrete dam structure of the weir. On the left here, you can see that there is a point bar, and on the right there, where there appears to be kind of the gray sort of wall on the right, that is a cut bank, and that is due to the wide turn it takes around the corner here, and has been eroded along the side there. Where that erosion is occurring, there's a high amount of energy, and then when it turns at the bottom, beyond this thalweg right here, see this? This is where there is also a couple nick points where it goes from lower, it kind of dips in, goes from a higher amount of topography, lower, and then goes higher and then lower. As I'm pointing here, you can see I'm still pointing at the thalwegs right here where it makes the turn. There's a couple nick points as it does go down, change into topography. Here you can see where the stream meanders even more, and then there's another side of right here there is another thalweg as it curves again. The velocity along the side of the wall here, as you can see there's white water, does speed up quite a lot as it hits the side there, and then curves around. As it curves around and the velocity starts to decrease, there is a low amount of energy. In other words, there is deposition. Here I'm going to take you closer to get a closer look. On the side here is another kind of cut bank. You can tell there's quite a lot of damage along the side here, and that tree roots even need to be tied back. Here's another closer look at how the stream meanders and curves. And as the topography goes from high to low, the stream discharge increases as there is a change in topography. It also changes the velocity as it curves around the meander, just as I explained before. It goes from the higher energy, curves, while it curves and hits the side of that wall there where it was eroded, that is a thaw wag, and then continues around the curve and slow down to a low energy, in other words, deposition. Here's me showing you where it slows down and where there's a low amount of energy at the bottom of these two curves. In conclusion, Douglas Creek watershed is quite a very unique water system. It is a meandering stream that contains thaw wags, a cut bank, a point bar, lots of areas where there's high energy and low energy, where lots of erosion from the stream coming around the side, and then low energy where a bunch of the sediment is transported. Within the creek, there is quite a lot of nick points as it changes topography from high to low. The weir needs to be updated eventually to prevent the salmon being harmed from contaminants flowing over the weir instead of through the system. Thanks guys for watching. I hope you enjoyed learning about Douglas Creek.